Welcome to our tutorial on linear regression. This linear regression tutorial is going to be based off of the TI-83 and TI-84 calculator is what you see on the screen currently. TI-84, TI-83 are both going to work very similarly. What we're going to do is we want to take the data set highlighted on your screen. And with that data set, we want to answer certain questions, as you now see on the screen. We want to determine the equation of the line of best fit, determine if the line fits well, and make some predictions. So what we're going to do first is we're going to put this data into our calculator. There's a stat button on the calculator in the middle of the screen. In that field, we want to edit our stats. Now, if you already have some numbers in your calculator that you want to eliminate, it's pretty simple. What you do is you scroll up until the L1 is highlighted. You then hit enter, and you should see this blinking cursor on the screen. Hit the clear button, and then hit enter again, and all of those data points are erased. At this point, we're going to type in 4, 7, 9, 13, 18, oops, I want that to be 18, and 20. Please double check to make sure that you entered them correctly. I always do a spot check then, 4, 7, 9, 13, 18, 20, 4, 7, 9, 13, 18, 20. Then hit the right arrow key, and we're putting the y values into L2. 12, 18, 22, 30, 44, and 56. Again, I do the double check where I compare what I have in L2 with what my y values are. The other thing that I like to do at this point is make sure they have the same amount of numbers in each list, which I do, so we're good to go. Now, the main thing that you care about doing is calculating the linear regression. But first, I will also discuss how we looked at the stat plot. So to look at the stat plot, we went second y equals, and we made sure that stat plot 1 was turned on. Hit enter, make sure you hit enter on the on, and we wanted to use this little box, and we wanted dots. Then we went into the window. Well, the smallest x is 4, so let's make the smallest x value 0. The biggest x we have is 20. Let's make our x max 25. The smallest y we have is 12. I'm going to make y min 0. And the largest y we have is 56. I'll make y max 70. When you have that window filled in, hit graph, and that will show a picture of your data. Here, the data is sloping up, so it will be a positive correlation. And actually, it looks like a pretty good line. That's what we really care about. This is nice, but this won't be the key item on a quiz or a test. In order to figure out the equation of the line, we go into stat. And we want the calculator to calculate something for us. So we scroll over to calculate. We want the linear regression ax plus b. Be careful, in class some of you chose the linear regression a plus bx. You want option 4 here, linear regression ax plus b. Hit enter. Now if you have a TI-84, it might just pop up and say x list, it should be L1, y list, it should be L2, and you just hit calculate. For those of you with the 83 or certain 84 models, you hit second 1, that says L1, which tells the calculator your x values are in L1. Then you hit the comma, which is right above the 7 key, and go second 2 for list 2. That tells the calculator that your y values are in L2. We hit enter, and there's part of our answer. Now be careful here. The reason I say to be careful is because what we need is we want the r value as well. You should only have to do this once, so many of you will see the r on your screen. I'm going to need to hit second and then 0 to get into the catalog. When I'm in the catalog, I need to scroll down to the D's, and I want to find Diagnostics On. hit enter, and then just immediately hit enter. It turns those diagnostics on. Now remember we discussed in class if you don't want to retype something you've typed, you can hit second enter to scroll through those lists. And now I'm going to do that linear regression again. Ah, nice. Now we need to actually interpret those items. So now that we have our linear regression output, I'm going to write the equation of the line. Y equals, now the slope is the 2.6169. I'm going to put 2.62x plus, well, the y-intercept is negative, so it's really going to be minus 0.63. At least 2 decimal places correctly rounded. On the homework key, I typically put 3 decimal places, and if I have a specific preference on the test, I'll let you know. Does the line fit well? To answer that question, we must look at the R from the output. So here we see that R is 0.985, and I'll write that out. R equals 0.985. Since that is close to 1, it is a good fit. Now what we said in class was if that R value is 0.8 or above, or if it's negative 0.8 to negative 1, it's a good fit. So when we see an R like this, we're happy. The line is pretty well representing the data. Look at problem number 3. We want to predict the value of y when x is 10. Well, all we do is plug in 10 for x, so we'll plug that in. We'll type it in our calculator. Now, if you kept more decimal places, your answer is going to be a little bit different. I am not going to get finicky about that on a test or a quiz. This turns out to be 25.57. Is that a good, reliable prediction? The answer is yes. Because the value of x there, x equals 10, is in the middle of our table. That was called interpolation when we discussed in class, because it's inside the values in our table. You're able to predict well with data that is in your list. Now when we do the other problem here, predict y when x is equal to 100, we plug in 100 for x, and we'll actually calculate that. I'm getting 261.37. Unfortunately, that's not a reliable prediction because it's way outside of the x values in our table. We were using x equals 100. 100 isn't even close to the values we have. When we did that in class, we called it extrapolation. E-X-T-R-A-P-O-L-A-T-I-O-N. Basically, it's like saying, can we accurately predict what planet Earth will be like in the year 2300 right now? Well, no. It is so far out of what we know that while we could make some predictions, they're not going to be particularly reliable. Last but not least, predict the value of x when y is 100. So we would plug in 100 for y, we would set up our equation, and we would go to solve for x. We could add the 0.63 to both sides. And then finally we would divide by 2.62. I'm getting about 38.41. Now make sure you would circle or box all of your answers. So I'm going to circle or box all of my answers on this page, making sure it's really clear. Let's circle that one too. It is a good fit because it's close to 1. And of course we have our original equation. I'll just star that. Now for problem number 5, it also asks, is this reliable? And the answer here is going to be no, because that y value, y equals 100, is way beyond the y values in the table. So again, that would be the extrapolation. And when you're making a prediction that's way beyond the values you have, while it is a prediction, it might not be particularly reliable. The last item for this tutorial, let's put the line on our scatter plot. So I'm going to go back to the calculator, and what I'm going to do is go to the y equals. And in y equals, I'm just going to type this equation, 2.62x minus 0.63. Hit graph, and that would be a reasonably fit line to our data. Notice it goes uphill, it's a pretty good fit, and we can predict well when it's here. But once we go way out on the side, it's more difficult to have an accurate and reliable prediction. That is linear regression, and really the key thing is just knowing how to use your calculator. So simply put, what you're going to do is, remember, you need to go into edit in your stat. You put your data in there. Then you quit out. You can go second mode to quit. Go back into stat. You want to calculate the linear regression. When you calculate that linear regression, this output comes up on your screen, and then you just interpret it correctly. Thanks for watching linear regression, and hopefully this process goes well for you.